This is lesson 6.3. We're going to be going into something called the product rule. And so the product rule, as you can imagine, is some sort of multiplication rule. So in my next video, I'm going to be talking to you about the quotient rule. Now, before I get into the product rule, I do want you to understand how to graph not only a function, but its derivative as well. So remember that the derivative is the slope. Okay, so when we graph the slope, we actually graph the slope function. This is going to be a little bit tricky, and so I'm just going to show you how we dissect it. Okay, so we have -2 right here, and this is our 1. We have two peaks there, and if I start to look at my slopes, okay, this slope right here is a slope of 0. This slope right here is also a slope of 0. Okay, now just to be clear, this is our original g at x function. All right, now within these regions, you'll start to notice that the slopes act a certain way. Okay, now I'm going to start off, and I want to use the same colors that I had used before. Imagine this slope right here of this tangent. It's super positive because it's super steep, like 10. Okay, and then we have the next slope, which is maybe like 9. This one looks like it's about 5. Okay, maybe this one would be about 3. And notice that the slopes are decreasing because eventually at the very top, you're going to have a slope of 0. So this side is actually all positive slopes, but they're decreasing in steepness. All right? Now, let's talk about the middle. The middle from -2 to 1, that region, I'm going to use a blue. Okay, now going past that first peak, this is a negative slope. Now that might be -1. This could be -3. This could be -7. And this one is the most negative. But then all of a sudden you start to get closer to the second peak, which is -5, -4, -1. So notice that the negative slopes, the negative slopes are going to be increasing at the beginning and decreasing at the end. So this entire region is negative slopes. All right. And now we get past that next peak, and it's all going to be positives again. So this is going to be positive slope, even more positive, very positive, and so on. So that's what I've written at the bottom, each of the domains for the sections of where the slopes happen to be. Okay, so you have a positive slope anywhere from -2 to 2, and from 1 to infinity. You have negative slopes just in the middle from -2 to 1, and then you also have 0 slopes specifically at an x value of -2, which was your max, and then also at 1, which was your min. That really helps you visualize if you start to draw the slope graph. And so this guy is going to be our g prime at x. Okay, now the way that we see this is, imagine you had taken all of the slopes, all those random lines that I drew on the left-hand side, and you applied that understanding to the right-hand side. And so notice that the pinks first, actually, you know what? Why don't we start off with the 0 slopes? This guy is your slope function. So when m is 0, that happens at -2 and at 1, because at -2 and at 1, that's where your slopes were 0, right? Okay, so that's -2 and this is 1. Now, within the region of -infinity all the way to -2, we had a positive slope. Okay, now this slope, remember, was very positive, less positive, less positive, very little, very little, very positive, less positive, very little, all the way to 0. In the middle, from -2 to 1, you had something that was not very steep, negative, more steep, and then less steep, less steep, less steep. It's going to go like this, back up to 0 again. Okay, so notice that this is the negative region. of the slopes, because they're negative m values, these are all positive m values. Okay, so on this side, we're going to start to increase again in this region, and so this goes right back up, and you get something that looks like a parabola. That should make sense because this g at x looks a lot like a cubic graph. And so if we do the derivative of a cubic graph, we do the power rule, right? Bring it down. 3x and then 1 less for its power. This is just a parabola. I'm hoping that that makes a little bit of a connection for you, because we're going to get into something a little bit different now, which is the product rule. That graphing thing is always difficult for a lot of people. It took me a while to actually get it. So derivatives. Taking the derivative of something that looks like this guy is pretty complicated. And so what we could do is just lighten it by doing the distributive property. Like if you just did FOIL and you had everything in a nice line, like a polynomial line, that would be easy because then I could just use the power rule. So taking the power, multiplying it, I'm going to get 20x to the power of 1. This is a 1. Doing the derivative of negative x is going to be taking that 1, bringing it down, negative 1 x to the power of 0, which is just 1. So you know what? I'm just going to write it as 1. And then taking the derivative of the negative 3 is 0, so I'm not even going to think about it. That's it. That's as fast as I can do it. For the next one, oh my gosh. Okay, so two polynomials that are trinomials multiplying each other, that is a lot of work to do distributive property this much so that you have an entire line of polynomial. That is huge. It doesn't look that much, but like I did all the work on the side, and here we go. That is the answer. So we can finally do the power rule with each of these terms. Okay, and you would get 24x to the 3, 57x squared, 72 with an x. This 34 is just going to be 34 because that is going to be x to the power of 0. And then this is just going to become a 0. So that looked really fast, but I mean, it's just this part. Like doing the expansion is going to take forever. And so it would be great if we had some sort of a rule that works with the product of two functions. So if we have two functions and they're actually multiplying each other, it would be great to have some sort of a rule to do the derivative without having to expand first. And that is where we get something like this. So the product rule, when you have two functions that are multiplying each other, you can always take the original of one of them, multiply by the derivative of the other, plus the original of that second one multiplied by the derivative of the first. And so each one gets its own turn to be a regular function multiplied by the derivatives of each of them as well. And you're adding, so it really doesn't matter which order you put things in. So let's tackle those same first two questions without having to do all of the expansion. Okay, so I'm going to use different colors. This guy's going to be my first one. We'll call that U. And then we'll say that this one is my V. And I'm going to jump right away into the derivative. So f prime at x, keep the first one the same. And then do the derivative of the second. So the derivative of 2x is just 2, because that x is going to be to the power of 0, and it's going to disappear as 1. And then the 1, the 1 is going to become a 0 anyway when I do the derivative. So that's the derivative of v. Plus, now you're going to keep v alone. Don't touch it. But you're going to do the derivative of the first one. So the derivative of u is going to be 5x. Nope, not 5x. My mistake. Just the 5. Okay, because 5x to the 1, 1's going to multiply, right? You're going to get 5x to the power of 0, and then that's just going to become a 1 anyway. Close that off. And then that is your derivative right there. Now you can clean it up a little bit just by multiplying, simplifying. This 2 can multiply each of these guys, 10x minus 6. And then the 5 can multiply each of those guys, plus 10x plus 5. And then we get 20x minus 1. And isn't that what we got before? So let's try the other one. And again, this one was the one that was super, super long if you decided to do the expansion. So let's try the product rule instead. F prime at x equals to, keep u by itself, don't touch it, take the derivative of v. So that's 4x for the first term, minus 3 for the second term. And then that 5 becomes a 0. Plus, I'm just going to start a little bit lower. Keep v by itself, but take the derivative of u. So that's going to be 6x, doing the power rule, minus 5. And that 3 is going to disappear. Okay? Now, depending on your teacher, you may or may not have to expand. For myself, I don't want my students to expand and simplify that. All I want to know is that they know how to take the derivative. And so you can stop right here. This is the answer. I don't want to go any farther because, I don't want them to do the distributive property. When it's something like this one's pretty easy. You can expand and simplify very easily. But this one is so much work to do the expansion again. I can obviously see that they know how to do the derivative, and so just leave it right there. This is my own preference. You're going to have to go through whatever your own teacher says. Okay, so example number 3. Find the slope of the tangent, aka do the derivative. Okay, so we have an original function, which is this guy right here. We have a specific point that they might want, okay, and then find the equation of that tangent line. So the very first thing I want to do is I want to find the slope. Okay, so the slope is going to be y prime. We can do the derivative, and so we have the derivative of these two. Since they're multiplying, I can use a product rule. I'm going to keep my u exactly the same, but I'm going to take the derivative of my v. And so that's this guy right here. Because the 4 is going to disappear, right? But the 1/2 is going to come down, multiply, and then it's going to subtract a 1 in the exponent. Plus, the other part of my function, no, I'm trying to say derivative. Sorry, my derivative is keep v by itself, but then take the derivative of u. Now, I would stop right there. I know that there are exponents that are negatives, but the question itself is not asking for you to have like a really nice function for like a nice expression for your slope. What I actually want to know is give me the equation of the tangent. So this entire equation. I don't really need a fancy like function for my slope. So why don't you just immediately put 4 in? Okay, put 4 into wherever you see an x. So all of these x's right here, you're just going to put 4 in right away because my point is I want the slope when x is equal to 4. Like I just want a number. All right, so once you start solving, you'll find that when you substitute 4 in, you actually get a slope of 75 over 4. Okay, so that's the slope of the tangent. What I'm then going to do is I need a point because once I have the slope and a point, I can then find the equation of this tangent line. So to find the point, I'm going to substitute that 4 into my actual equation. Okay, so into the original blue function, I put the 4 in and I get my point, which is 4 and 18. Now that I have my point and my slope, I just put it into y equals mx plus b to find the equation of the tangent. So you guys know how to do all that. And it's not that tricky. The only thing is it's the exact same types of questions that you've seen. We're just now doing the short form using the product rule. Okay, Okay, so where can we see this in real life? You might see them in certain kinds of formulas, like say revenue or business. So for example, revenue is made up of, if you think about revenue, like how much money you could possibly make, you would find that by taking the price of an item multiplied by however much of that item you have. So in this question, we have example number 4. The volume of a crop is given by, I'm just going to underline that, V at T, where T is the number of weeks from the beginning of the harvest. You also have the price function as well in terms of T. And so to write the function of the revenue, what you want to do is you want to multiply them both together. So I'm just going to write V at T is the negative 60 T squared plus 800 T. And then the price, which is 10 minus 0.4 T. Okay, so I'm not going to expand that because I want to start using the product rule. So in B, what they've asked us for is how is the revenue changing after 4 weeks? When they say changing, they mean the rate of change, i.e., they want the slope, okay, which is also your revenue prime. Okay, so the derivative of your revenue equation. What you can then do is sub in 4 once you're finished and sub in 6 once you're finished. Okay, so let's take a look at what our equation would look like first. All right, so we have our U and we have our V. Okay, so our U, we're going to stay the same, negative 60 T squared plus 800 T. Okay, we're going to change up the V. The derivative of the 10 is going to be 0, and the derivative of the negative 0.4 T is negative 0.4. Plus, okay, we're going to keep V alone. Don't touch it. 4T. But we're going to take the derivative of U. Okay, so that's going to be negative 120 T to the power of 1 plus 800. All right, now, since we have that, again, we don't have to expand it or anything because what we want to do is we want to answer the question. The first question said, what happens when we're at 4 weeks? So I don't really have to expand it because I can just sub the 4 in right away. So that's, you know what, use square bracket. Negative 60, I'm going to put a 4 in for T squared plus 800. And again, put a 4 in for the T. We're going to multiply that by negative 0.4 plus 10 minus 0.4 times 4 for the T. Negative 120 times 4 plus 800. All right, and I'm sure you guys can do the math, blah, 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 equals to, let's say about 1,792. Okay, I'm going to just put that up a little bit. What does that actually mean? Well, it means at week 4, okay, because you're talking about when T is 4, your revenue is, and this is a rate, like this guy that you just found is a rate, so you're going to say it's increasing because it's positive at a rate of, this is our dollars, because we're talking about revenue, and revenue is obviously in dollars. So $1,792 for every week. That's what the rate means. Okay, so it should be a per week kind of thing. Now, if you were going to look for the 6 weeks, our prime at 6 actually ends up to be negative 448. And so if I were to write a therefore for that, I would say at week 6, the revenue is decreasing. Whoops. At a rate of positive 448 because it doesn't make sense, like negative 448 as a rate for dollars. So the negative you're going to say in terms of this word decreasing, but you're going to keep the positive number. So positive $448 per week. All right, so that little tool of just using the product rule, so much easier than having to expand and just tweak your original function first. So obviously I'm going to give you some sort of functions that have division in it as well, so like fraction functions. So I mean, those ones, we'll just use the quotient rule. So I'll show you that in the next video.